ALS Rochester. Appreciate everybody joining me today to talk about some passive sampling of groundwater, what it is, how it might be beneficial for you, some of the pros and cons, and how ALS might be able to fit into that equation to help support some of your projects. So start off here. There we go, passive sampling. So start off, we'll just talk about, well, what is a passive sample when we talk about, getting in there and sampling passively for groundwater. The ITRC, which is the Interstate Technology and Regulatory Council, defines passive groundwater sampling as the collection of a water sample from a well without the use of purging by a pump or retrieval by a baler. It allows you to collect a representative sample of the aquifer immediately adjacent to the specific position on a well without the active transport that you typically get induced by pump and purge techniques. Passive samplers rely on diffusion as the primary process that drives their collection of chemical constituents. So we're going back to basic chemistry here. Chemicals tend to move or diffuse from areas of higher concentrations to areas of lower concentration. This diffusion leads to an equilibrium concentration being reached. So our passive samplers have type 2 DI water inside them, which reaches equilibrium with the ambient water in the well. So with passive sampling, again, there's no active transport water from pumping or purging. So you're not going to be pulling water from above your screen interval, below, adjacent areas. It's all going to be collected right from your screened interval at the specific depth that your passive diffusion sampler is hanging. So the sampling device is hung in the ambient well water. It reaches equilibration, and during that deployment period, which is typically about 14 days, so you don't get any of the disturbance to the well and the aquifer that you might have from bailing or pumping. So it's going to reduce any turbidity that you have in your sample. It's going to give you much more of a representation of what the natural conditions are inside the well, because you aren't actually physically disturbing it prior to collecting the sample. Talk about some of the diffusion samplers. Now there's probably a dozen, maybe more different types of passive samplers for water. We'll talk about specifically the two that ALS is able to supply, and these are kind of the original passive samplers for groundwater. On the far right here, this is your passive diffusion bag samplers. So we make two different variations of this. On the far right here is an unfilled passive diffusion bag, also known as a polyethylene diffusion bag. And then directly next to it is your pre-filled passive diffusion bag. So pre-filled with ASTM type 2 DI water right from the organics department of our laboratory. The pre-filled and the unfilled, they're made of the same material. They work exactly the same. The only difference is that the unfilled one, you fill it in the field with your DI water. So sometimes that can be easier for transport in the field, depending on the site. Then over on the left here, this white with a red cap is your RPP sampler, your rigid porous polyethylene sampler. Works in much the same way. It's filled with DI water. It reaches equilibrium through passive diffusion through the membrane of that polyethylene material. On the right here, these passive diffusion bags, they're used mostly for volatile organic compounds, whereas the RPPs are typically used for inorganics, dissolved metals, nutrients, anions, and also used for some of the more water-soluble organics that we get lower recoveries on the passive diffusion bags. So that's what we'll be talking about today, and hopefully by the time you leave this webinar, you have a better idea of certain applications that these samplers might be useful for moving forward. So passive diffusion bags, PDBs for short, they're polyethylene tubes or bags. They're filled with the analyte-free DI water. PDBs are hung in monitoring wells for periods of at least 14 days or until equilibrium is complete between the contaminants in the bag and the surrounding groundwater. PDB operates by diffusion of contaminants across that polyethylene membrane with no purging necessary. So it's a 4 mil thick, medical grade, low density polyethylene. These were originally developed by GE and USGS in the late 90s. They partnered with ALS at the time, Columbia Analytical, to manufacture, and they've been used now for 20 plus years. They've been used at hundreds of monitoring sites across the country and internationally. The data produced by passive diffusion bag samplers is considered as valid as that obtained from other conventional sampling procedures. Obviously, data is always the most important thing. We need to have usable data. And as long as the passive diffusion bags are used properly and for the right application, data quality will not be an issue. These are made fairly ruggedly. They're designed to withstand field conditions. So they're made from medical grade, high strength, low density polyethylene. They have heat sealed seams. They'll resist abrasion, and you'll see on the end here, there's a tab for quick attachment to a hanging assembly and easy retrieval for pouring into a VOA vial. So we make them in a couple of different sizes. Standard 2-inch well, the standard size is going to be 24 inches long by 1.25 inches diameter. On that, you'll hold about 220 mils, so there'll be plenty to fill up your 3 40 mil VOA vials. For a 1-inch well, we double the length, so 48 inches long, because they're only 3/4 inch diameter to fit into the smaller well, and you'll still get about 200 mils on that size. Either diameter, we can make those up to 48 inches long. So if you do want to collect additional volume in a 2-inch well, we can make those up to 48 inches long with 1.25 inch diameter to essentially double the volume that you'll be able to collect. We also are able to supply an optional mesh cover, which is this black thing in this picture here. We advise to have that mesh cover in the event that you're going to be having a well that maybe is a little bit older, is maybe in rough shape, maybe has some corrosion on it. You want a little bit of additional protection to protect the passive diffusion bag from getting hung up when you're deploying it and when you're retrieving it. So like I said, the low density polyethylene, it's just a semi-permeable membrane. It allows the volatile organic compounds to pass through. Bag is hung at the screened interval for 14 days to reach equilibrium. 14 days is generally speaking the minimum amount of time that you want to have it deployed. And realistically, they can be deployed virtually indefinitely. And that's definitely one of the strengths here is for long-term monitoring situations where you might be going out on site, call it quarterly or semi-annually, even annually. You can go out, you can deploy your passive diffusion bag, come back the following quarter, it'll be in equilibrium, retrieve it, collect your sample, and go ahead and deploy the next one for the following quarter. So from that aspect, they can be virtually left deployed indefinitely, and by the time you get out there to collect that sample, because there is the constant equilibrium being reached through that membrane, you will have a representative sample of the well when you collect that sample. So bags are easily retrieved from the well, cut open, transferred to the VOA vials. No additional parts are necessary. No real storage space is necessary. The handling is pretty easy in the field. Deployments and retrievals, they're super quick. And sampling into the vials is simple. You just snip off the top, pour it into your VOA vials, make sure you have no head space, and send them off to the lab here for your VOC analysis, typically by method 82.6. We're looking at a comparability study here that was done. On the bottom there, you see concentration of tetrachloroethylene in purge samples. And then on the vertical axis, we have concentration when sampled by a passive diffusion bag. So you can see that there's a very good correlation here. The data being produced by passive diffusion bags is comparable to your typical purged sample. Here we're looking at a cross section of a passive diffusion sampler being deployed into the well. So it gives you an idea of what actually is going on. Here we have two that are deployed in series. So still more or less in the same 5-foot screened interval. You can see on the bottom there's a stainless steel weight. We recommend those to counteract any buoyancy that you might get, especially if there's any wells over 100 feet. You definitely want to consider additional weighting to make sure that the PDB is actually sitting in the interval that you're intending to screen. These PDBs are hung in series. You can do that for a couple of different reasons. Of course, you can get additional volume by having an additional passive diffusion sampler if you need a QA QC samples or the like. PDBs can also be hung in series to screen different intervals. So this can provide information on stratification of contaminants and if your well has any hot spots, so to speak. If you want to have the upper PDB deployed, let's call it 75 feet, and then the second passive diffusion bag deployed, call it 125 feet, so you get about 50 feet in between the two. You can compare the results from the two and see, if you might be getting more results, less results, or the same in different sections of the well, and can be used to provide a little bit more information on any stratification that might be occurring inside the well. On top of that, they can also be hung in interval with passive diffusion bags as well as RPPs. So if you need to sample for more than just your volatile organic compounds, if you need to sample for dissolved metals in that same well, you can have a passive diffusion bag and an RPP hanging on the same line. Where we actually do produce the hanging assemblies that you might need. Of course, they can be hung using the standard nylon rope or what have you, but for many of these applications, you're looking at a long-term monitoring situation where it might be worth the upfront investment to have a stainless steel, non-corrosive hanging assembly. We supply those, and those can be either fixed, so you can hang your passive diffusion bags, whether that's 1, 2, 3, however many you need to hang. At that, call it 50-foot interval. We can also make them adjustable, so you can adjust that in the field. If you have any dynamic water levels, you want to take a water reading and adjust it to 55 feet in the field, 65 feet in the field. We have that option as well, and we also are able to produce them so that you can screen those different intervals. If you want to hang a passive diffusion bag at 50 feet and then hang another one at 100 feet. We can configure your harness assembly to do just that. Again, this is the RPP, the rigid porous polyethylene sampler. RPP samplers were invented not too long after the passive diffusion bags, sometime in the early 2000s. RPPs are made out of thin sheets of foam-like porous polyethylene, pore sizes 6 to 20 microns. When completely filled with water, the pores allow a water-water interface facilitating that same equilibrium of water-soluble analytes in the aquifer adjacent to the well screen with the deionized water inside the RPP. Like the majority of passive samplers, it is recommended that they remain deployed for at least 14 days. So those RPPs, they'll deploy with the plug end down, and they'll be kept in that position until transferred to the sample bottles for transport to the lab. So that just helps to avoid any leakage from the pores. They're about 5 to 6 inches long, 1.5 inches in diameter, and you'll get about 100 mil sample from the RPP. So this is what the device looks like itself. It's got the dieldrin cap on there that is removed to collect the sample. This picture on the lower left here is what you will receive upon shipment of the RPP. We ship them contained within polyethylene bags because the pore size is a little bit larger. If they're handled roughly, if they're squeezed in shipment, the water can seep out of those pores. So we send them in a water-filled sleeve for shipping. When you're ready to deploy, you just cut it out of the polyethylene bag. It's contained within that red mesh device, which is exactly where you're going to hang it from for deployment into the well. This looks at some of the analytes that the RPP is able to sample for. So we're looking at dissolved gases. That's your methane, ethene, ethylene, perchlorate, chloride, hexavalent chromium, nitrate, sulfate, your soluble iron. 14-day equilibrium time is pretty standard. Your water-soluble volatiles. So, like I said, there's certain volatile organic compounds that we don't tend to get as good of recovery on with the passive diffusion bags. For those applications, we do recommend using an RPP instead. Dissolved metals, some of these things, explosives, get into a 21-day equilibration time, and that's been demonstrated through studies that they do require a little bit of additional time, but to get that full recovery that you're looking for. So again, we're looking at data here. This is a study that was done for pump sample concentration versus passive sample using the RPP device. The graph here on the right is just a blown up picture of what we have concentrated here on the left. So again, you can see that there's a very good correlation between the two sample collection techniques, which does allow and produce reliable data. So what are some of the advantages of passive sampling? We touched on some of them already, and I'm sure everyone on here knows that highly reproducible, comparable data is always a plus when you know that you can rely on that. I've mentioned this, you don't get the drawdown that you get from pumping. So you're not pulling in water from different areas around the well. You're actually getting what's sitting in the well. You're not getting any turbidity in your samples, again, because it's just passively diffusing into the DI water inside the passive diffusion device. You don't run into those same issues that you get with pumping or purging. The passive samplers are disposable, they're dedicated, so they are one-time use. You deploy them, you collect your sample, and then you deploy a new one for your next sampling event. So you don't have to worry about any contamination between wells. You don't have to worry about decontaminating any field equipment between wells. It's one and done, and you move on. But one of the big advantages here is decreased costs, mostly in the form of reduced field labor. We're talking about a matter of 5 minutes that you can go out and deploy a passive diffusion bag into a well. come back 2 weeks later, another 5 minutes to retrieve it, deploy the next one. Compare that to, being out there if you're waiting for a well to refill or what have you. You could potentially be saving yourself a lot in field labor costs, time, and like it says here, minimal public visibility and interference. So you can be in and out, no large amounts of equipment to worry about, that sort of thing. You don't have to worry about any disposal costs. So if you are pulling purge water and you have to dispose of it afterwards, well, you might have to pay for that as well. With passive sampling, that's just not a factor. Same with the field equipment. No moving parts. It's a one piece. So it gives you the ability to sample in discrete intervals. I had kind of touched on this. You can do contaminant profiling. You can monitor for zones of highest influx. If you're getting no contamination at 50 feet and maybe off the charts at 150 feet, well, that gives you a little bit more information. These passive samplers don't have any depth limit either that we have to worry about. They've been used all the way up to 1,000 feet wells. No depth concerns. The only concern is making sure that it stays in that screened interval. And I touched on that with you may want to consider an additional stainless steel weight to make sure that it is staying there, especially if you have an especially deep well. With the pre-filled samplers, we use our ASTM Type 2 DI water right out of our organics laboratory, and we are able to provide a certificate of analysis to prove that that's clean water. I'll touch on this in a moment. That you can also use the passive diffusion bags and the RPPs for sediment pore water sampling. And I mentioned this. We can deploy these in series to get additional volume, monitor additional contaminants, etc. As with everything, there's going to be some limitations. Of course, volume and analyte limitations are definitely one of the most common things that we run into. With the passive diffusion bags, we're really only sampling for volatile organic compounds. With that, the volume isn't as much a concern because the passive diffusion bag does hold enough volume. But when we get into the RPP samplers, there may be volume limitations that require, depending on what you may be sampling, for multiple RPPs to be deployed in order to collect a sufficient amount of volume for the lab to be able to complete that analysis. In general, you do need to consider contaminant stratification. This was touched on as a benefit, and it is something to be considered as well. As far as a limitation, you are screening a specific interval that the passive sampling device is hung in. And of course, we do have to wait for them to restabilize and re-equilibrate before sample collection. So it does require a little bit of forethought and planning in terms of proper timing of deployment, so that when you are ready to actually collect the sample, the equilibrium has been reached within the passive sampler, so you are getting a representative sample. The passive diffusion bag, it does only sample for VOCs. Like I mentioned, you get lower recoveries for ketones, ethers, and alcohols, and some of those more water-soluble analytes. They tend to not recover as well. The RPP, I had mentioned it does need to be stored and shipped fully immersed in DI water. We send them to you in that polyethylene bag. It's just up to you to keep it in there until it's ready to be deployed, and that's to make sure that you don't lose the DI water that's within the sampler, which is ultimately going to end up in your sample bottles once it's reached equilibrium. The RPPs haven't been tested for all analytes. You may need multiple samplers to obtain a sufficient volume. you might need advanced techniques or methods to analyze for SVOCs, and some of the equilibrium times may not be as well. So the harness assembly is something that we're able to supply. I've mentioned we can supply these specific to your well. So in the event that you do have a long-term monitoring situation where you're going to be going out there monthly, quarterly, semi-annually, or annually, and plan to use passive sampling consistently on this site, those are situations where we generally will recommend that you go ahead and make the investment for the full stainless steel, non-corrosive hanging assembly. It's non-contaminating, they're completely reusable. They can be left in wells between sampling. Of course, generally, it's going to be with the passive sampler attached to it. All replaceable parts, we're happy to help out with replacements. They can be made to be adjustable in the field. And we have configurations available for any type of well cap, whether you need a safety disc, a hook, or what have you, a clamp. We have multiple options depending on what sort of well cap it might be, 2-inch, 1-inch, otherwise. This diagram here on the right just gives you an idea of what you're getting when you're ordering a stainless steel harness assembly. We are able to customize this top section. Again, it can be a hook, it can be a fixed loop, it can be just the safety disc. We can give you a little bit extra line on the top there. The clamp where the passive diffusion bag is actually hung from in the well, we can make those fixed. We can make those so they can be adjustable in the field. We can add multiple different points where passive diffusion bags or RPPs can be hung from. So if you do want to look at different intervals at a 50 foot, at 100 foot, at 150 foot, we can design these and manufacture them specifically for that purpose to be able to fit your particular need. And they always come with a stainless steel weight to help out with getting it into the screened interval as well. This is just a little demonstration of a cost savings analysis that we were looking at for a Superfund site versus using conventional sampling techniques. We were able to determine that time savings, cost savings, lowered expenses. You're able to save about $250 per well per event using passive diffusion bags to sample for VOCs. This particular site had about 30 wells sampled per event. So I'm really saving about $8,000 per event. Annual savings about $25,000, plus any additional savings that you might get from having to dispose of the purge water and that sort of thing. I mean, even with implementation costs, if we're calling it $3,000 for harnesses, and if you would like to, or if a regulatory body is requiring any sort of comparison study to do side-by-side results to confirm the data that's produced, you're still able to recover those upfront costs in about 3 events. So as far as regulatory reactions, I mean, the EPA or any state agencies, they don't technically approve sampling technologies. Regulators have routinely approved sampling plans that include the use of passive samplers. We've done these in just about had clients use these in just about every state as well as internationally. The EPA and there's also state regulators that have guidance documents on passive sampling for groundwater, and it's really, if you work it into your sampling plan and you have the justification for it, it's something that most regulators should be at least tangentially familiar with at this point, and there is plenty of guidance documents that can be pointed to as well. there's still some innovation going on in this category as well. This buoyed passive diffusion bag, I think, is a pretty cool application of how these can be used for surface water applications. It's designed all the same as a regular passive diffusion bag. We just have a little buoyed section, so just filled with air closed into the top, so that it keeps the passive diffusion bag near the surface of the water level. It can also be used if you have any dynamic water levels and you want to make sure that you're keeping equilibrium with the surface water. This will be effective for that purpose. Have mentioned, hey, these things can be used for sediment sampling as well, pore water. So this we don't supply these, but it's very basic PVC, perforated PVC. You put a cap on both ends, slide your passive diffusion bag in there, and stick it in the sediment, and that'll get you a representative sample. And you can do just the same with the RPP sampler as well. Ongoing research, there's some further research required in looking at using RPPs for wider suites of organics, looking at longer deployment times, looking at the possibility of making these with additional sample volume. But the issue that we have is, once we extend these past that really 6-inch mark for the RPPs, because of the pore size, they tend to start to just leak a little bit more, and that's kind of what we're grappling with. As I mentioned, there's lots of guidance documents out here regarding passive sampling. These go far more in depth than I'd be able to in a webinar. There's years and years of studies. These guidance documents include passive diffusion bags and RPP samplers, but they'll also provide lots more information on other types of passive samplers as well. These are all produced by the ITRC. There is actually a more recent one here, recently published, I believe 2020 or 2021, the most recent update, but it all more or less recaps the same information of applications for groundwater sampling, when they should be used, when they shouldn't be used, what contaminants to use these for, and any drawbacks. So it just goes much more in depth than I'd be able to here in a half-hour webinar. So that about covers what I had to say on the subject. I'd be happy to answer any questions. And again, I thank everybody for joining me here for this today.
Thank you, Michael, for the great content. Before we begin the Q&A, I would like to ask everyone to take 2 minutes to complete the survey. The link is in the chat section. We would love to hear your feedback. We will open the forum for questions now. Please write your questions using the Q&A function in the toolbar at the bottom of this webinar. Attendees can also see all submitted questions using this window. I will give everyone a few moments to type in your questions. In the meantime, I will review some brief notes. This webinar presentation has been recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS global website and our ALS YouTube channel in the webinar playlist. Also, please follow our company page on LinkedIn as we post announcements and registration links to future webinars and other resources and updates. We're so happy everybody is here today. We have a big audience, and if we're not able to answer your questions, please reach out for us for assistance. Our first question coming in is from Carl. I understand that you have to leave the sampler in the well for at least 2 weeks. However, can I deploy them and pick them up 90 days later?
Yes, absolutely.
Okay, thank you. Gary's asking, are the diffusion samplers available through ALS service centers?
So the diffusion samplers are all manufactured and produced here in ALS Rochester. We have an online portal for ordering. So we can get them out to any of the service centers. We can ship them directly to you as the client, but they are really only kept in stock here in the Rochester lab.
Raphael would like to know, is the monitoring well purged before deploying the passive diffusion sampler?
No. The passive diffusion sampler can just be deployed as is.
David is asking, do you have a recommendation regarding when to collect water quality, physical measurements, pH, DO, temp?
That I don't have a recommendation on, unfortunately. That's not something that I'm as familiar with, and as far as when those should be collected in the field.
Keith would like to know, sampling of dissolved metals was mentioned. What about total metals?
Yes, so the RPP sampler is only able to be used for dissolved metals. We do not currently have a passive sampler that can be used for total metals.
David is asking, do you ever have problems with biofilm or mineral deposits impeding transfer of VOCs if the bag is left in the well for an extended period of time?
No, this actually isn't something that's ever been an issue for any of our clients. So not that I've been made aware of.
Chris is asking, what information was used to develop the recommended deployment time?
So this was originally based off of just bench studies looking at comparability and recovery rates. It was found, I believe, that they were done with a 7-day, a 14-day, and a 21-day equilibration period. And for the majority of parameters, there was no additional recoveries beyond that 14-day period. The few that there were, which I had noted, some of the explosives and a couple of the dissolved metals required a little bit longer of a time to get the full recovery.
Kelly is asking how to dispose of used bags for RPP.
They can just be disposed of in the trash, essentially. It's just your typical plastic for disposal.
Matt is asking for longer term deployments. Example, could freezing of groundwater in the well over winter potential cause any issues such as damage to the samplers?
No, this is not something that we've had an issue with in the past. Our field team actually uses these for certain applications. We're up here in Rochester, New York, which, you know, we see our fair share of winter, and nope, haven't had an issue with that.
All right. Chris would like to know, is there a recommended solubility limit for the PDBs?
That I can't speak to, unfortunately.
Christian's asking, are there differences between these sampling methods and hydrosleeve sampling method?
Again, the hydrosleeve is something that I'm only kind of tangentially aware of, and would not consider myself an expert by any means. So I can't really speak to that either.
David is asking, are there any QA/QC samples associated with receiving an RPP? Does anyone sample or document the water volume quality?
So if you're referring to the DI water that's inside the RPPs, yes, we test every single lot that leaves the lab to make sure that it does that it is free of any contaminant before. Yep.
Okay, Jeff would like to know, how long does the ALS analysis account for groundwater flow and mass flux over time, potentially delivering more mass to the sampler intake, say over 2 months versus 2 weeks?
There isn't actually, so to speak, water flowing in and out. I mean, of course, there's the contaminants flowing in and out, but in terms of, you know, active transport of water through the well, it wouldn't really have any impact. It's going to remain in equilibrium regardless.
Jeff is asking, with no purging of the well prior to installation of the diffusion samplers, how do you know you are not just collecting a stagnant water sample?
That's a good question. That's probably something that's a little bit outside of my technical capabilities in terms of the hydrogeology of it. There's certainly could be instances where, you know, if you have a stagnant sample that it could require pumping or purging. But again, that kind of goes outside of my technical knowledge.
Michael, can you hear me?
Yes.
Yeah, David is asking, would diffusion back samplers be suitable for volatile fatty acids?
That's not one that we've seen before, and this does go a little bit into the limitations of these devices. As some of these we're not sure on. If there would be, it would be the RPP sampler for the volatile fatty acids, but again, it's not something that's been studied as far as I'm aware.
Thank you. Yuri is asking, is there a maximum time a PDB can be at a well before sampling?
No, these can be left deployed in the well virtually indefinitely.
Jeff is asking also, are there good comparison with purge samples results at the higher concentration shown in the graph also observed at concentrations near the MDL or drinking water MCLs?
Yeah, yes. I believe it's regardless of the concentration.
Jackie would like to know, are the water samples representative of the last 2 weeks, even if the sampler has been in the well for 3 months?
Yes, because the diffusion will just continue for as long as the device has been deployed. It'll continue to reach equilibrium as long as it's deployed, so that when it is retrieved, it's representative of the current conditions of the well.
Okay, Keith is asking, how much are the PRB, RPP assemblies each? Was it about $100 each? Then how much approximately per event materials?
Yep, so the passive diffusion bags, the pre-filled variation is $28.50. The unfilled variant is $20 each. And we do give discounts if you order 51 or more at a time. Those prices do apply regardless of the length that you are purchasing. And the RPP samplers, again, those are just the 6-inch length by 1.5-inch diameter. Those are $65 each. The hanging assemblies, those are custom size to order. So those have to be quoted on an individual basis.
All right. Kelly would like to know, are there larger bags for 4-inch wells? Are there different lengths available?
So there aren't any larger bags for 4-inch wells. What we have had clients do in the past is hang multiple PDBs. It gives you a lot of extra room. So you could hang 2, maybe even 3 passive diffusion bags from one point on the line in a 4-inch well, so that they're all in that same screen interval. And as far as the length, yes, we make them up to 48 inches long for both 1.25-inch diameter as well as 3/4-inch diameter.
Do we have any more questions? Well, I would like to thank everybody for attending our webinar today, and I hope everybody has a good week.
Yeah, thank you. Thank you everyone for joining us, and thank you Alejandra for facilitating this. It's been wonderful.
My pleasure. Bye-bye.